Target 8.3. I can calculate the percentage composition of a compound from a formula or from decomposition results. First, we'll focus on how to calculate from a given formula. To find the percent composition of anything, you just divide the part you're trying to find over the total, multiply by 100, and that will give you the percent. For example, if we were going to find the percent girls in this classroom, we would count the number of girls, and we would count the total number of people, and then we would divide girls by the total number of people. So girls would be the part, 17 over 30 times 100, and that would give us the percent girls. I'll let you do the math. The same thing is true with a chemical formula. For example, we will find the percent composition of water. When you're asked to find the percent composition, unless they ask for a specific element, you find the percent composition of each element in the compound. So we're going to do this. We're going to need the periodic table to calculate. We will add up the molar mass of water based on 2 hydrogens and 1 oxygen. So I'll look at the periodic table. There are 2 hydrogens, I get that from here. 2 hydrogens, and this is hydrogen's molar mass on the periodic table. Each hydrogen has a mass of approximately 1 gram. There is just 1 oxygen. The molar mass of oxygen is 15.9, so I rounded it. So 2 times 1 gives us 2, that's hydrogen's part of the molar mass. 1 times 16 gives us 16. Add those together and there's your total molar mass, 18 grams in 1 mole. So now to get the percent oxygen, I will divide 2 by 18. 2 divided by 18 times 100 gives us 11.1. So water is 11.1% hydrogen. To get oxygen's part, you'll divide 16 by 18 and you get 88.9. You can check your work by adding the percentages together and you should get really close to 100. If you don't get 100 exactly, it's just simply because of rounding. I'm going to do one more example. I'm going to find the percent composition of aluminum sulfate. First, I determine the number and type of atoms present. From this subscript, I can see that we have 2 aluminums. We have 2 aluminums. That's Al. Times, I'm going to multiply that 2 by aluminum's molar mass, which I get from the periodic table. It's 26.9, so I'll round that to 27. I can see that I have 3 sulfurs. You distribute 3 sulfur. Sulfur's molar mass is 32. And I have 3 times 4, or 12 oxygens. And oxygen's molar mass is 16. Now I multiply across. 2 times 27 is 54. 3 times 32 is 96. 12 times 16 is, someone help, 92. Add that. And we get 342 for our total. Now to find the percent aluminum, I will take aluminum's part over the total, so it'll be 54 divided by 342 times 100, and that will give me percent aluminum. I think that's about 56. Then I will take sulfur's part of the total, 96, divide that by 342, multiply by 100, and that will give me the percent sulfur. And then I will take oxygen's part, 192, divide that by the total, multiply by 100, and that will give me the percent oxygen. These percentages should total 100. Now I will go ahead and do the math. 96 divided by 342 times 100 is 28, and 192 divided by 342 is 56. This one must not have been 56. 54 divided by 342 is 15.7. Or 15.8. Now if I add those three together, 15.8 plus 28 plus 56, I get 99.8, and the only reason it doesn't equal 100 is just because I didn't keep my decimals here. So I know this is a good way to check it. It should be really close to 100, especially if you've kept your digits. That's how you do percent composition from a formula.